5. Okay, so I'm going to do a little weird walking back and forth because I don't have a keyboard yet for this monitor, so it's going to be a little funky, so I just walk back and forth here. But we talked about Python functions, and the point of functions, if you remember correctly, are to create segments that wrap our code and contain parts of our code and have a useful function that we can call and reuse multiple times. So here we're going to start playing with some functions and working with them. And I think if we start to think in the context of functions, it'll be really helpful for you guys later in your career and when working with packages and sklearn. So let's try this. I'm going to give you guys just a minute here, a couple minutes here. We're going to do some hands-on exercises. So I'll take some time, let you guys think through this, try to code it. Exercise 1, we're going to calculate the square of a number. So write a function named square that takes a number as an argument, and the function should return the square of a number. And we can test it by passing 4. So this is calling the function, if you remember. We can call the function 4 or square, pass 4 as an argument, and see the results, which should be 16, of course. Okay, let's spend 2 minutes on that, 2 to 3 minutes on that. Is that in what?
I think you have to.
I'll come over. Oh yeah, I think there's one more notebook to open for you. I think we've got 3 out of 4. If we go to, let's go back to this drive. This one, and if we go to, not that one, that's missing.
Yes.
Yep. So student folder. And go to functions. Yep. And then download the exercises, Python functions and exercises. It's down. So these 2 dots here.
Today's 28th or what was it?
Not the examples, but the exercises. Yep. And then back to your drive. And from the downloads folder, put that in here. Okay, perfect. So exercises, I'll look that one. Here we are. Enter it. Now you should be able to put some code in there. Okay. Stop this. Write a function named square. How should we start with this? We're going to do something called pair programming. Pair programming is when you have one person driving and writing the code and another person telling that person how to code or what to code. So, def, you got it. Square. X, you got it. Oops. And then what?
We've done
Excellent. Returns x star star 2. X is what's going to raise it. The star raises to the power of. X is the parameter and raises to the power of 2. So anything that we pass will now be raised to the power of 2. So we can call square 2. We can check this out with a couple different numbers, and it's going to work for us. Excellent. All right, exercise. Next exercise, write a function named isEven, and it takes on a number as an argument, and it returns true if the number is even and false otherwise. I should have said spend a few minutes. I'm going to do.
Will you scroll back up for me, please?
Oh, yeah. You got it.
Okay.
Okay. Let's try her out. Exercise 2. So we're going to create a function isEven. How should we do that? DEF. Even. X. Oops. Colon.
And something about if x over 2 is an integer, it's true.
So f over 2 is an integer. Type x is equal to int. Then it's true. Is that what you were saying?
If x divided by 2 is
Oh.
an integer, then true.
By 2. If x divided by 2 is an int, then true. else false. Let's see. And we called this even. I'm just going to change it to is even to match our. Oh, we got an error. Oh, so I like to just talk through errors as we get them because this is very common. So we got an exception here. We said it says if type X is int, so it's telling us where in the code this error is coming from, and then it's even giving us a little indicator here where it ran into that error. So and it says it expected a colon. In my if statement here, I forgot to put a colon at the end. And we got none here for this. So how should we fix this code? Let me see. I think I have a sneaking suspicion that that's not the proper way to check if something is an int. I'm going to leave this up here so you guys can see it. But let's do this. How to check if X is an int. Let's do it this way. How would we debug this? We might check to make sure each line is working. So what we would expect from this is true, and what we would expect from this is false. So we did get true, false from that. So that piece.
Can you just take the after the if part on its own and then put a number for X just to test it?
Yeah.
Would it give you a true or false?
Yep, we can.
Just copy the.
We still got none.
What about type? Will we take out the type? Since we added function.
That's a great idea. Let's take out type. Let's see if int is int. Oh, we're still getting none.
So what if we took out type and then had a number times without the without the divide is what I was thinking.
So we're saying if is even X, if int is int, which we know is working, and then we're saying true, else we're saying false. Why are we getting none when we call our function?
Is there an error? Would it be an error?
What do you guys know about Python functions? When do they return none? So we have a function here, is even, and it's when we call it, no matter what we pass to it, we're always getting none back. What are the situations in which a Python function might return none?
When no argument is passed.
When we don't have a return statement from our function. What are we missing? We're missing our returns. So we can't just say true. We have to return true. So that is something called a semantic error. Syntactical errors are ones that actually break the program and are produced to your screen. Semantic errors are harder to debug. There was logic that we had that was incorrect in the program. And when the program ran, it looked like it ran correct. It didn't get any errors, but it was serving us semantically the wrong answer at the end of the day. So now we can put this back in. Now that we've taken that piece of code out and tested and debugged it, and we can try to put this back in, x over 2. And now we are getting, so we did type x over 2 is int, return true, else return false. So now we're getting a different error. This is the nature of programming. You fix one error, you get another one. We're getting false for both 5 and 10. And 5 is correct, but we know the output for 10, when we say is even, should be true. What do we think is happening here?
I think you will have to change the function.
Say that again.
I think you will have to change the function, because if you like 10 as an x divided by 2, it's 5, which is not an even number. So
How should we change? Yes, so she said that we have to change the function because 10 divided by 2 is 10 is an even number, and 10 divided by 2 is 5. And 5, type of 5 would be an integer. How should we change the function?
you can use the percent symbol
Awesome.
or
So
the modulus.
modulus operator, I like it. X modulus what?
Then that's where you would put the 2 and equal, that will equal 0, so that shows an even number.
Awesome. We got our program working. So x modulus 2 double equals 0. What we're saying here is that when, thank you, that's excellent. When we pass in x, if we divide by 2 and the remainder is equal to 0, modulus operator, remember that gives us the remainder. If the remainder is equal to 0, then it's true. Otherwise, it's false.
Which one is the modulus sign?
The percent operator, the percent here.
And what is modulus?
Modulus means give me the remainder. So let's look at this. I love questions like that because we can just look at it in the notebook. Sorry, I don't know why this thing is being funky. So 10 modulus 2. Oh, it's supposed to be modulus. I apologize. Modulus 2 is 0. 5 modulus 2 would give us 1. So 2 goes into 5 2 times with a remainder of 1. 2 goes into 10 5 times with a remainder of 0. So this will give us the remainder. If we did like 5 modulus 3, for example, we would get 2. What's the remainder remaining after we take 5 divided by 3? It's kind of a neat operator in in programming, the remainder. Okay, calculate the area of a rectangle. So write a function named calculate area that takes in two arguments. It takes in length and width, and the function should return the area of the rectangle. So set the default values of length and width to 1 and test the function with two different values for length and width. DEF. Oh, sorry, I'm on the right screen. There we are. DEF.
Calculate underscore areas,
Got it.
parentheses, x comma y, colon. Next line. Return x star y, colon.
Excellent. Do the colon. And we got an error. So we got invalid syntax, and it points to this colon. I think in the return function, we shouldn't, fix one error, you get another one. In the return function, we do not need a colon at the end. That's a good thing to point out. So I'm going to rerun this in a slightly different way here so we can see this. Okay, we got an error. We got a type error. But look, it said 15, and then this part is underscored red. And we got a type error here, and it even points to the line. So this is how you read Python errors. It even points to the line. It tells us line 7 here, print calculate area. So because we see 15 here, we know that we got to the first print statement. And so we know where our error is coming from is in the second print statement here under calculate area. And the error we're getting is calculate area is missing two positional arguments, x and y. What do you guys think is the problem here? It's missing numbers. So if we go back up to our problem definition, we said create a function named calculate area that takes in two arguments, length and width, and the function should return the area of the rectangle. Set the default values of length and width to 1. How do we set the default values of length and width to 1?
I calculated the numbers. And the numbers into the parentheses instead of the.
We could put the numbers in the parentheses, and that would be passing arguments to the function. But here we're asking to set the default values. Yes.
X equals length and y equals
X equals length.
is it width times length or width?
Maybe it's half with times.
X equals length and X equals width. We can try that. Oh, length is not defined. So the program doesn't know what length is. We're getting a name error.
Could you put like length in a different, like those definitions in a different line?
Should X equal 5 and width equal 3?
You're right, yes. When we pass 5, 5 takes on the value of X here, and 3 takes on the value of Y. So instead of, we could call these length and width instead, and maybe that's what you're saying. Should we call these length and width instead? So now we have length times width. We can call them X or Y. We can call them length or width. I'll just leave this up here. So we know that this is essentially the same. This is the same thing that we're doing down here. We just named them differently. But we're still getting our error here. It says instead of saying missing 2 positional arguments X and Y, now it says it's missing 2 positional arguments length and width. How do we set our default values? So the problem we're facing here,
Is length, you just say that length or width are numbers rather than strings?
So the equal.
equals what? Equals
X or Y.
equals set the default values for length and width equal to 1. Equals 1. Yeah. So now when we call this function, even though that we're not passing anything here, even though we're not putting anything in the parameters, length is taking on the value of 1, and width is taking on the value of 1. We could have done that with X and Y too. If we said X equals 1, Y equals 1. The naming doesn't matter. The equal sign inside of the function definition is what's going to allow us to set defaults. Okay, this is going great. I'm glad we did the exercises. This is helping, I think. There's nothing quite like actually trying to program something to really ground programming. It's the only way, unfortunately, that you really learn with programming is just trying things out. Let's write a function named greet, and it takes a name as an argument. So it should take a name in the function definition argument parameter. And the function should print a custom greeting, such as hello name, and modify. We actually might have done this in our slides, so it's a little bit of a redo, but modify the function to include the default value for name equals guest, and then test the function with 2 names. So this is maybe a bit of a review because we definitely did this in the slides. Spend a few minutes on this. All right, I think now we know it's always going to start with def and the name of the function that we're creating, and we're going to end with the colon. And we know we're going to have to return something, so we'll start with this as the format. Does this function require any parameters? Are we defining any parameters here? What should we put inside these parentheses? Name. Do we need a default value?
Yeah, we want to say yes.
Guest. All right, and what should we return?
I put
Great.
Print. Name. Or print name. Print. What should we put inside for the grading for our hello? Then how do we put the name in there in the hello?
And we put it outside, outside the quotes.
If we did name, should we try it? We got a invalid syntax. It says, perhaps you forgot a comma.
We put a comma.
We could put a comma. Where should we put the comma?
Put the second.
Yeah. There we go. Hello, guest. Hello, Alice. There are different types of print statements. So if we just wanted to print this, we could print it that way. Oh, it's supposed to say this. Just with one quote, we could say print this with two quotes. We could say print this space, comma 5, which is how we did it up here, where when we're making a print statement, we can separate it with a comma, and it will print that variable in addition to the text that we're printing. Or we can do a print format where it's printf, this space, curly brace, 5. The curly brace tells the program that it's code that it's going to run. The reason we need that is because if we had my variable equals 5 and we tried to print this my variable, the program doesn't know if you want to print the my variable variable or if you really want to print the text my variable, because maybe you're talking about your variable and you want that printed to the console. So maybe we want to say my variable is awesome. And maybe we want the second my variable to actually be the variable. We could use the format print where we put an F here. And if there is an F in front, anything inside of curly braces is recognized as code. So now when we run this, it'll say my variable 5 is awesome. It recognizes that my variable is text that we want to print, and that anything inside the curly brace is code to execute, which in this case is a variable name referenced to a value of 5.
Inside the curly what?
Inside the curly brace, these purple curly braces. But that will only work if you have an F in front. So let's try it without an F and see what happens. It's called a format print. Let's take away the F. And if we try to do that, we're going to get my variable. This my variable is awesome. So my variable, including the curly braces, becomes text, becomes a text value. The F indicates to the Python program to search for curly braces and convert curly braces to code. Okay, so a little bit about print statements there. Great. I think we're a little more comfortable with functions, which was my goal. And now for the next couple of minutes, we're going to talk about data exploration briefly with pandas and matplotlib. And then we're going to take a break, and then we're going to do assignment 1, and then we're going to take a break, and then we're going to do assignment 2. And that'll be it for today. So we're all hands-on exercises today. Okay, we are going to start to leverage some packages. Again, weird back and forth. I don't have a keyboard, so I'm going to pop back over here. Let me make this larger here. There we are. And in Python, it is kind of a best practice to import all of your packages that you're going to use inside of your notebook at the top of your file. So here I'm going to make these are called our import statements. And I'm going to pop this up a row. There we are. So these are our import statements. We're going to import pandas as PD, import numpy as np, import matplotlib.pyplot as plot, and we're going to import seaborn as SNS. That's the common nomenclature for seaborn is SNS. We're going to run that. And now we have all of our packages that we're going to work with.
You want us to follow along?
You guys can follow along in this one. This one isn't a homework assignment, so you can follow along or run some stuff. I'll probably ask you guys some questions. It might be easier if you have it open. I am just going to one thing that you can do with here, I just wanted to get this. One thing that we can do with our packages is check what version they have. So packages are a lot like your cell phone. It's technology, and people contribute to it, and they update it, and they make changes. So the sklearn for a long time was in beta, which means it wasn't even in version 1.0. Now, if we look at sklearn, it's in, I think I can pull up sklearn. Okay, here's sklearn. So now you guys know what I'm talking about when I keep saying sklearn. So sklearn is a machine learning package in Python. And this is what we will use in our machine learning course. And you guys will learn classification, you'll learn regression, you'll learn clustering, and we're going to use this Python package to do that. And that's why this class is really important, because we don't have enough time to teach Python. We just dive right into sklearn. So we assume that there's some foundational Python knowledge, which is why we talk about functions and variables and such things in this class. So sklearn has a version. You can see that sklearn is 1.61 is the stable release version. And you can see that version 1.7 is in dev. And you can see that there are other versions that have been released. So we can go to different versions of sklearn and look at the documentation, the API that they have. The API that they have for those different versions. So we can roll back to different versions in sklearn. Where this becomes relevant is that different developers can be working with different versions of a package. Maybe you installed sklearn on your machine 6 months ago, and you're using sklearn on your machine, and it's a different version than what I'm working with. And sklearn released some cool new feature that lets me run a metric in a new way, or run a new metric, or do a pipeline in a different way. And you try to run my code on your machine and it doesn't work because your machine doesn't have that feature because you're working off of an old version, an old release. This is why we use Google Colab, because it enables us all to be on the same version. When you guys ran that notebook, assignment 0, at the very beginning of this class, that's what it did. It checked to make sure your versions were compatible with the packages that we were using in this class. So full circle there. But if you want to check your version, you can call __version __. So here I checked the version of the pandas package. We can check the version of the NumPy package. Put a few more cells in here. Let's check the version of the matplotlib. You know what? It has to be actually matplotlib, not pyplot. I might have to import matplotlib. So we're going to get matplotlib is defined because I said import matplotlib.pyplot. I didn't actually import matplotlib itself. I nested down one. So we need to do import matplotlib if we want to do that. And then we can do Seaborn. And I talked about sklearn. We can do import sklearn version. So all these packages have different versions, different releases. What you see now may be something that different from what you see for the releases of these versions. This will make more sense as you guys get to the API course and you start talking about releasing your code and saying what version each package is on for package dependency management during the API course. Okay, so that's package versions. Great. So the next step, we're working with a data set. We imported our packages. The next thing we want to do is we want to load our data. Break this down a little bit. So we're going to load a data set into a data frame called using SNS, so Seaborn. Many of these packages have toy data sets for you to work with. sklearn has toy data sets. It has a Titanic data set. It has an Iris data set. The Titanic data set's kind of fun. You get to predict who you think will survive the Titanic. And I'll let you guys think about some features that might influence whether or not somebody survived the Titanic. It's a really fun one. I use that in the machine learning course. I do not use this one, so I wanted to use a data set that was different. Good luck with your speech.
Thank you.
So here we're going to load a data set. Seaborn has data sets that we can play with. We're going to do that here so we don't have to go through the work of finding a data set, downloading it, uploading it to your Google Drive, making it accessible to your notebook. We can definitely do that too, but we're just being quick here. So we're using a toy data set that exists within the Seaborn package, and it's called tips. So we're going to call sns.loadDataset, and we're going to pass in tips. And the first thing we're going to want to do, well, I would be curious to know what type is that data? I mean, we called it DF, but is it a data frame? What did Seaborn put it as? Well, the Seaborn data set loaded it in as a pandas data frame. So we know that we're working with a core pandas data frame. And then next thing I would be curious to know is kind of what does my data look like? Let's look at the first, I'm going to simplify some of this. Let's look at the first 5 rows of data. Actually, I think it's df.head. I think that's going to give us the first 5 rows of data here. All right, so we have a data set, and it says total bill, tip, has a gender, whether or not they were a smoker, the day, the time, whether it was dinner or not, and I assume the table size. So we've got some tip data set data, and we want to just kind of explore the data and look more at it. One of the first things that I find useful to do when we're looking at this data set, the first question that I have is, well, I can see how many columns that we're working with here, but we can check that out. I want to know how many columns that we're working with. And data frames have this function called columns. So we can call df.columns, might be columns. There we are. And we can get all of the columns in our data set. If we want to get, so we get the columns in our data set. If we want to get the count of the columns in our data set, I mean, here, maybe it's very easy. We can just count. We can say 1, 2, 3, 4, 5, 6, 7. But maybe you're working with a really big data set and you have to scroll and you want to know how many columns you're working with. We can say length of df.columns. And we know that we're working with 7 columns. Length is a function that returns us the length of a list. And since columns is a list, we can run length on that. So we can do type of df.columns to validate that. Well, it's an index actually, but columns at 0 is a list, a string. Okay, it's an index. We can take the length of this as well. Okay, if the next question I'm going to have is how many rows are in my data set. So we can run length of data frame, and we see that there's 244 rows. So we know there's 244 records in this data set. Pandas has a really great function to tell us this rows and columns in a more succinct way. And it's called, so we can find out rows and columns in a more succinct way. And it's called df.shape. So if you run df.shape, you're going to get back a tuple. We know what a tuple is. And you're going to get back 244, 7. And 244 is our number of rows, and 7 is our number of columns. So df.shape is one of the first things I do when I open up a data set. I just want to know what's the size that I'm working with here. What's the dimensionality of the data that we're looking at? Okay. So we did that one. The next thing that I'm moving some of these out of order. The next thing that I'm going to call this part. I'm trying to organize this a little bit. After I know kind of what the makeup of the rows and columns of the data set are, my next question is, well, what are their types? We can kind of look at this and we can kind of guess. And I can say, oh, well, I think total bill is a float. And I think tip is a float. And I think sex is a string. But is it? Like, you could represent total bill as a string. That's a bad idea. And if it is, I want to know that because that's going to affect my data analysis. I can't put things on a scale. I need to convert that to a float. And so what we're going to do is to investigate. So the first thing to investigate, and the second thing to investigate is the data types of my columns. Okay, so we're going to investigate the data types of our columns by running df.datatypes, df.dtypes. Yep, takes me a minute sometimes. So df.dtypes will actually tell us the data types of our columns. So now we know total bill is a float, tip is a float. We have categories for sex, for smoker, for day, for time, and for size. So now we know what we're working with, what the data types are being represented by those columns. Category is, I think that's going to be a pandas.
Well, that's a custom
it's going to be a pandas. I'm going to give you my 80% answer because I have to refresh on this. But I'm pretty sure category is a pandas type that allows us to have very designated buckets of values that things should fall into. So think about banana. If you're classifying fruit and it's apples, bananas, or pears, that's a categorical data type. And the reason pandas has categories is because that's very important for machine learning. So when we create target variables or do feature engineering for our predictive models, the categorical variables often behave differently than like string variables, for example. Let me think of a good way to describe this. Okay, if in machine learning, so it's a data structure in pandas, or data type in pandas. Data structure, same thing. If we have in machine learning, if we have fruit, and it's a, let me think of a slightly better one. One second, I'm trying to think of one relating to houses. Because it's a really simple data.
Room types.
Say again.
Room types.
Room types. Yep, there we go. Okay, so room, thank you. Type. So say we have room type, and we have a bedroom, and we have a bathroom. And we're trying to predict something off of this. We're trying to predict our Y, which is how much value this would add to your house, maybe. And maybe this is like square feet or something. Okay. 1, 2, 3, 4, 5, 6. And there's another bathroom here. So there's multiple, is what I'm saying. 7, 8, 9. Okay. So this occurs in here multiple times. In machine learning, if this is a categorical variable, we can often pass that to something called one-hot encoding. Which is going to convert that to bedroom. It'll be like room type bedroom, room type bathroom, room type, the third room type. And then these become binary indicators. So bedroom was 0 here. So it would be, is there bedroom in row 1? Yes. Is there bathroom? No. Is there bedroom? Is there room type 3? So this is called one-hot encoding, where we're taking, there are 3 categories here. And we're taking one column and we're converting it into 3 columns, which are one-hot encoded to binary representations for a machine learning algorithm. The whole why we do that, we'll talk about in the machine learning class, but the short answer is because we need to convert this to numerical representations for machines to understand. And if we just did 1 here and 2 here and 3 on the other one, we're basically saying that room type 3 is 3 times as important as bedrooms, and bathroom is twice as important.
So it's relative, right?
Yeah. So we can't do, this is called ordinal encoding if we did 1, 2, 3. And ordinal encoding implies when you do math, you should multiply it by twice as much or 3 times as much. That's why we do one-hot encoding when things are not ordinal in scale.
You assign like a value to them somehow?
Exactly. You assign a value to them. So it ends up being, and we're going down the rabbit hole, sorry. When we have like y equals mx plus b, this is our best fit line formula. You can extend this in machine learning to be y equals beta sub naught plus beta sub 1 x sub 1 plus beta sub 2 x sub 2, where our b becomes here, and this is just m1 x1. We can extend this to basically m2 x2, and that's where this becomes this becomes this. So x's are our columns. So x would be the room type or the square foot, and then these would be our numbers that we're finding through regression. So it would be y equals, like, I'm going to make up some numbers. 5 plus 10 times room type plus 5 times square foot. Right? This is not real. I just made this up to show you that, yes, you do multiply them by a number. So if room type was like 1, 2, 3, it would be 10 times 3, 10 times 2, 10 times 1. So what we do is we one-hot code these so that we're not telling the model that for categorical variables where there is no ordinality, they're not worth 3 times as much. Variables that do have ordinality are things like education. So a GED is ranked below a high school diploma, which is ranked below a bachelor's degree, which is ranked below a master's degree, which is ranked below a PhD. So there is ordinality in some things, but there's not ordinality in other things. That was such a rabbit hole. I apologize. Have I encouraged you all to take the machine learning class?
Good infomercial.
All right. This is an advertisement. So we can run D types on this to get our data types. One of my very favorite, I say this about every function that comes with pandas, but one of my very favorite functions in pandas or features about pandas, I guess it's a function, is this describe. I think this df.describe is so nice. So we get, just in one look, it'll tell you all the columns in your data set that you're looking at. So total bill, tip, size, our numerical columns. Notice our numerical columns. And it'll give us the mean, the standard deviation, the minimum value, all of our quartiles, and the maximum value. It is such a nice sanity check. One of the first things I do is I open up df.describe and I look at this and I say, well, a house worth $30 million seems unreasonable for this data set. I bet that's an error. Or a house worth, or if we look at the minimum, if we're looking at house prices, this is not house prices, but if we saw a house price worth $1, that's probably something that we should look at. So I like the mean, standard deviation, the min, and the max because they help me narrow in on things that might be wrong with my data set. And oftentimes, your data is really bad when you get it and you have to fix it. It's usually humans are entering things and they make typos and mistakes are made and there's outliers and we have to fix that. So coming in here, seeing, you should have an assumption of like what you expect to see for a minimum value, what you expect to see for a maximum value, the standard deviation, about what the mean would be, and if that's reasonable. So I really like the df.describe function. I've got 2 more here. Okay, so those are I've got one more on got one more on under this bracket of something to investigate the data types of my column. So we investigate the data types and a little bit of the distribution, but we also want to investigate the null values. And then after that, we're going to do part 3, or what did I say it? Call it above. I called it second thing, third thing. Okay, I just wanted to keep that on there. So I guess maybe df.describe should have gone down in the value distributions of our columns. Sorry, I'm going to move this down here. Okay. All right, the next thing to investigate are our null values. So we want to see where we have nulls. So we can run df.isNull. Will give us a what's called a Boolean mask of whether or not we have nulls. So if you run df.isNull, it's going to give us true or false values of whether or not this column of that row was null. That's kind of hard to read. So a better way to do it is to put a sum function on the end, and we can get a count. So you can chain functions together. This is called chaining functions together. If we run df, and then we call .isNull, you can call after that .sum, and that will give us a count. So in our data set, we actually have no null values. So we're counting our null values, and we're getting nothing here. Okay. The next thing, the third thing that I investigate right when I open up a data set, yes, we investigate our numerical values, our standard deviation, our min, our max, and our mean, but we have to do the same for our non-numerical values, which we know what they are because we went up and created this. We know that total bill, tip, and size are ints. So size, tip, total bill, but we have all these other categories. And we should investigate those as well. So we have day, and the way that we can do that is with value counts. I'm going to take some of this code out of here so it's getting narrowed down to what we're doing here. So Pandas has, first of all, before we get to that, the way that you select a column is to call the Pandas data frame and then the name of the column that you're trying to select. And that'll give you just the column. And remember, in Pandas, a column is called a series. So this will give us just the series. And now we can apply operations to that series. So we can get the value counts of the day column. And this will tell us, when we're looking at the day column, how many counts do we have for Saturday? How many counts do we have for Sunday? How many counts do we have for Thursday? And how many counts do we have for Friday? So this gives us a record count across all the values. It's a group by, essentially. And we can do that for all of our columns. I think there's two more in here. It's really helpful because if I had pulled this up and saw that there were some nulls or some other values, I might need to handle it. If I'm only expecting male and female, and I see a couple of records in there that say, like, I don't know, just Oreos, or I don't know, I have Oreos over here. So if we're expecting something different than what we see in here for data analysis, this is helpful to know. Okay, what were the other? We had time and smoker. DF at time, got value counts. Oh, I didn't put there we are. DF at smoker, got value counts. Okay, so we have dinner and lunch and smoker, yes and no. So now we kind of know what our data looks like. We know that time is only dinner and lunch. There's no breakfast in there. We know that smoker is only yes or no. There's not a maybe or a sometime. So the first thing I do when I get a data set is just make sure I have a good grounding in it, and I understand what the values are and what I can expect from that. If we needed to, part 2 would be to clean the data. We don't need to do any data cleaning. So we get to move right on to data visualization. I'll pop a few of these up here and then we'll look through these. And then we'll take a break because I know I'm running just a little long, and then we're going to do homework. Okay. Just wanted to show.
Value counts.
Value counts. I use it all the time. Value underscore counts. And you do have to have the parentheses afterwards. Okay, so now we can start to create some visualizations. We can plot a histogram of the total bill. To do that, we would call our plot.figure. We would pass some figure size, 6'4". We can play around with these and see what this does. And if we made this like 20, we can see that it changes the size of our chart here. Maybe we want it long. So you can play around with this visually. If we change the 4, let's just make that 10 for fun. Oh, wow. Now we get a really tall chart. So this is very, you can customize this to present it in the way that you want. And then we're going to call plot.hist. Hist is the actual histogram that we're building. And to hist, we're going to pass df at total bill. And we're going to set the bin size, the colors. I'm going to show you guys one thing here real quick. You might ask, well, how do we know what to set and all those features? And that we're supposed to call that. You can just Google, but also I find it useful to talk about something called documentation. Python packages and all packages have documentation associated with them that tells you how to use them. And I think the best programmers out there are the ones that are really good at reading documentation. I think the first time you read documentation, it's extremely overwhelming because what does all of that mean? And it's like it's not very friendly to look at. It's very clearly a developer designed this. However, I think it's very useful. Once you get used to reading one type of documentation, like Matplotlib documentation, the next time you read sklearn documentation, it's easier. And not everything is on the internet. And packages update, and they come out with new versions. And the people who are able to like parse and read and understand the documentation are just set up better to actually use and learn how to, because Python is an evolving language, the packages are for it. So you're set up better if we can figure out how to use this. So the way that we might read this, this is the hist function. So I wanted to create a histogram, and I know I need to use hist, and I want to know, well, oops, it's trying to help me. I want to know what am I supposed to pass to hist? So I see that I'm passing bins and color and edge color, but how did I get to that? How did I know that? In this documentation, that's what it'll tell you here. So it says, hey, matplotlib, hist, it takes in X. And notice we know how to define default parameters. We just learned about that with functions. Notice that all of these have an equal sign associated with them, except ignore the keyword args. Those are all default parameters, meaning we don't have to pass those to it. But notice X is not a default parameter, has no equal sign. That means X is required. So we have to pass X to this function. Let's try it out. Let me just, let's try it out on this line above.
So these three, what you were showing us, it was map, the first package, and the other two are sub-packages?
Oh, that's a good question. They are all independent packages. They're all different packages. Matplotlib is different from Seaborn, which is different from Pandas.
No, if you can go back.
Oh, I apologize.
I'm confusing you with my question because I'm not sure. Up there, in the title it says Matplotlib pilot.hist.
Ah,
Are these three different packages, or is that a package, function, something?
that's a great question. Let's go look at it. And then we will take a break because I know we are going a little long, so I apologize. This is important though. Let me figure out. I'm not used to this. I want to go to the actual code. Let's see if this will take me to it. Nope.
How do you access the documentation?
If you Google Matplotlib HIST, it should be one of the first things that
Or you
come
just
up.
Google it, it's not within like data, within,
Oh, is it within Google Colab?
right?
Well, it will try to help you. So if you hover over this, it will try to tell me things like useful things like this. So it, in a way, it is serving me some documentation through here. But if you want to read the web page documentation,
Okay.
yeah,
So you
you
just
just
go
go to
there.
Google. One second. I want. Here we go. Okay. This. Let me look it up over here real quick. We were looking for pyplot.hist. Pyplot hist. Those are all examples. Okay. Here we are. So here is when we import. This is a terrible description. I apologize. I'm more familiar with the sklearn package than I am. I'm not very familiar with Pyplot and how this is organized. But this is what a package is. It is truly just folders when you boil it down, and a bunch of Python Python files, and they all work together. So when we call this is matplotlib lib matplotlib pyplot. So when we call import pyplot, this is what it's actually importing. And you can see that some developers have come in here and been very thoughtful about all the import statements that they need to bring in, type checking, and then there's functions inside here. Basically, they're made of a ton of functions. I'm oversimplifying here, but they're made of a lot of functions that do very specific things. And then when you import your code, these functions call each other in order to bring that functionality to life. I don't know if I'm describing that well. It's kind of hard to look at because this is very well curated code by exceptional developers of the internet. And so it's going to be somewhat ambiguous here. In sklearn, we do look at the sklearn code. So this is when you call, to answer your question, when we say matplotlib.pyplot.hist, usually that means matplotlib folder, go into the pyplot folder, then go into the histogram folder, if I'm oversimplifying. So it's sort of like a directory search. You can think of it that way. Within, that's how I would say for now. When we get to object-oriented programming next week, some of that might fall a little better in line. Okay, so we can see in this histogram, if we call total bill, we can actually call plot.hist with just one parameter. What happens if we try to call plot.hist with no parameters passing to it? Oh, we got an error. Expected one positional argument. And this we would have known if we had read the documentation and seen that in here. And we can also see in the documentation, we can also scroll down in this documentation and it'll tell us what these parameters are. So it'll say X. What does it expect for X? An array or a sequence of arrays. It expects input values. What does it expect for bins? So these are all the parameters that we can pass. We can pass bins, we can pass range, we can pass density, weights, cumulative, and it tells us what we can and what we can't do for those, what values are expected for those. So basically how you interact with Matplotlib is defined through the documentation here. So we can look these things up. And that's why we can pass bins, we can pass color as sky. So if we come in here, I can probably find bins. Oh, bins, it's an int or a sequence. And it's an integer and it defines equal width of the bins in the range. So if I'm coming in here and trying to figure out, well, how do I change the color of it? I can scroll down and say, oh, there's a parameter called color. Well, what do I have to pass to color? It's a color or a sequence of colors, one per data set. The default is none, and it uses the standard color sequence. So then I can come in here and pass sky blue as a color to change the color. So the documentation really tells you how to use the package and what values you can pass to which functions. I would say hist is a function within the package. So, okay. I think that's good. Let's take a break. That's enough for packages. We're going to take a 10-minute break. We're going to come back and we're going to do assignment 1.
So, whatever.
My case is that not every owner wants to do it because some of the lots are abandoned or they're zoning, and I think that's where everybody gets nervous because they don't want to do for once in a while temporary deal that it's about in business, but they don't want to do like an umbrella catch-all insurance over the.
What about with the actual truck insurance?
They carry, and even the services that find me truck clients, they carry up to 20,000. But you have acid and you spill acid on somebody's lot and it's you know.
All right, sorry, we got stuck in discussion. We are back now. We're gonna go through assignment 1. So I do have this other notebook in here. If you're curious, there's I like to make games out of things. We've been talking a lot about functions. If you want to see how functions can work together to actually become a game, I kind of wanted to go through this, but it's 7:46, so I want to make sure we're still moving along and you guys have time to do the assignments. So that's what we're going to focus on. But this is a guess the word game. That's kind of fun to play with. It is in the repository, and it shows how when we create these functions, they don't just have to do one. Each can have its own one thing that it does, but they can play and connect together, essentially, and bring out some functionality. So let's talk about assignment 1. Directions here. In each of these code blocks, I'm going to say, hey, this is where you're going to put your code. So there's a spot for you particularly to put your answer, because in the future I'm going to have auto grading. So the examples are given. There are examples of what the output should be, how you should test your code. Just make sure that it matches that exact format. And I'll let you guys read the rest of these. But this is just saying match the format. And you can comment your code if you'd like. And there are examples. And if you're stuck, feel free to reach out. Hints are given for some questions. And you can use anything from the Python standard library. Okay, I did show some point totals for each question in this assignment, and then as the assignments progress, I don't necessarily break down the point grading for each and every single assignment. It's just you get more and more independent as assignments progress. The first one is a tip calculator. So we're going to create a tip calculator. We're going to compute the tip for a meal, and it says fix it so it works correctly. I should have probably had some code in here. I'm missing something. So also change the lines to print to 2 decimal places. So we're just going to start from scratch here. Let's go ahead and create a calculator function that creates a tip for the meal. So the output should look like this. First, we want to enter the price for the meal. In order to do that, we're going to use something called the input function. And the input function, let me put this above. The input function, this takes feedback from the user, is something that will take feedback from the user as soon as my notebook starts up and say I give 5. You see that 5 gets printed to the screen. So it takes feedback from the user and returns it. Functions return things. And so it stores that feedback from the user, from the console, and then returns it. If we want to use it somewhere in our code, we have to store it into a variable. So we have to say value equals input from user. And let's say I say 5. Then we can print on the next line, we can print value. Sorry, I have to kill this because it's waiting for my input. My bad. I print value, and we can see that value takes on 5.
Excuse me, Emily, where do I find this?
This Python programming assignment is in the Slack channel. I dropped this right before class.
Thank you.
it won't let you double click it to open it. And like if you
Okay.
download it and then drag it into Google Colab. Okay. So that's what the input function is.
It's not, let's drag it in.
Let me know if it's giving you a hard time. Okay, so the first thing we want to say is enter the price of the meal.
But it doesn't look like that, so maybe I didn't, so, okay, we can have that first.
Okay, I'll help you right after here. The first thing we want to say is enter the price of the meal. And maybe we want to assign that to a variable called meal price. Now, if we don't put a space here, it's just going to, put 10 right next to that. So we're going to want to put a space there. Then we're going to say a 16% tip would be, and put a space there. And I'm just laying out what we need here. Print the total including tip would be, and we know we're going to need some total to print out here. And here, I forgot to put the F, a 16% tip would be, and we know we're going to need some tip to print out here. Okay, so we have to do, we know we have to calculate tip, and to do, we know we have to calculate total. And then we'll be able to, so we need tip equals, and we need total equals. So that's what we have yet to define. So we're going to collect the meal price. Let's say the meal price is 10. If we want to figure out what the 16% tip would be on 10, it would be 10 times 10, which is meal price, times 0.16. And that's going to give us our tip. So meal price, so we did this. We can get rid of the to-do there. So now we have to, let's test that. Let's pressure test that. I'm going to comment these 2 lines of code out so they don't run. Let's pressure test that. Let's see. Enter the price of the meal, 10. Oh, and we got an error. We got an error. So it says can't multiply sequence of non-int type float. So what happens when we collect input from our user, if we run type on our meal price, oh no, that's a string. So this is where we have to do our casting. Cast meal price to a float. So meal price equals float of meal price. Let's try it again. Enter price of meal, 10. There we are. So a tip would be $1.60. 1.6. Technically speaking, in our directions, it says it should be 1.60, and our 6 is getting cut off. So we can .2f. I think it's .2f. Let me see if that's gonna. No. What we need to do, maybe I'll leave this up to you guys because you can find it fairly easily on the internet, is figure out how to get that 0 to display. Format print this so that our 0 displays on our 1.60. Okay, the last thing we need to do is calculate the total. So we're going to uncomment these lines of code. Now we're going to work on the total part of our code. It's really great when you're programming if you test one part of your program at a time. We try to write the whole program and then test it. Sometimes we'll get bugs like we did before, and it's easier to debug one thing at a time. So here we have total. Total is going to be our meal price plus our tip. And we can print this out. We can say our price for our meal was 10. And now we have our total. Again, we need to maybe figure out how to get that 0 to display. Okay, I'm going to come help you out.
prompts to, how do we go back to close out here? Oh, I see where we're at. Okay. Okay, I think we click out of this. And if we search Google Drive here instead of, let's go to your Google Drive. Yeah, there we go. I'm gonna call this out. Okay. And we're gonna want to go into program notebooks. Okay. And we're gonna hit it. Now I think you can drag.
Okay, let's try that. So I try.
Yes. I was realizing that we need this to be a little easier for you guys this next class.
It's, you know, the thing
I was
is,
observing a little bit each class.
because I didn't, like, I don't know, like, what we're doing or why we're doing
Yes.
it or whatever, you know, and so.
We should just set you guys each up with your
Can
own
you
directory.
just a quick second? If-
Yeah,
if
yeah,
you can't
of
fix
course.
it, then I'll.
And then this should put everything in collab.
Oh, hit enter after the 5.
It's waiting for input.
Yep.
Oh,
Now we got your input. Now it's waiting for input down here. That's a good thing to experiment with it to, yeah, it's always gonna wait, it's gonna spin. That's the thing about input is it's gonna spin and wait for that input. You got it.
Yeah, well, no, didn't get it, but I know.
You're in.
Yeah.
You're in. I like it. Okay, excellent. There we are. Let's do 2.2, the gas pump. So let's write a script that prompts the user for the number of gasoline, number of gallons of gasoline, equivalent to liters. We want to format that for decimals, number of barrels of oil to produce, format to 3 decimals, and the price in US dollars. So 1 gallon is equivalent to 3.7854 liters. 1 barrel of oil produces 19.5 gallons of gas, and the average price of gas is $4.31 a gallon. So please enter the number of gallons of gasoline. So we're going to say gallons of gasoline equals, please enter the number of gallons of gasoline. The next thing we need to do is convert gallons of gasoline to liters so that we can do this print statement here where we will say printf 10 gallons of gasoline is equivalent to something, or it won't be 10, I'm sorry. Our 10 will be our gallons of gasoline. Which is 10 in our example, is equivalent to, and then we're going to want to say liters of gasoline. We haven't defined liters of gasoline yet. That's what we need to calculate here in order to make this print statement. Liters. Okay. Up above, it said that 1 gallon is equivalent to 3.7854 liters. So we can do gallons of gasoline is equivalent to 3.8. Oh, it's getting, AI stuff's getting ahead of me here. Put that down below. No, that's what we're going to do next. So let's try just one part of our code at a time. Oh, and we got an error, and that's why we try just one part of our code at a time instead of trying to build everything. So we got an error. Can't multiply sequence by non-int type of float. you guys remember why we got this error before in the last problem? Yep, that's it. We need to cast it. So when we take input from a user, it'll be a string. So we need to cast that. We could actually just cast it. We could do it this way, or we could just do it here on this line as well. So we'll just, there we are. That's the same thing. Let's try this now. 10. Yep, there we are. And now we have 3.854. We're missing a 0 here. I'll let you guys figure out how to format print that to print the 0. Let's do the next part. The next part is barrels of oil to produce. So barrels of oil is equal to, up above, if we scroll up, we can see 1 barrel of oil produces 19.5 gallons of gas. So gallons of gasoline divided by 19.5. And what we can say requires barrels of oil to produce. We can test this. Yep, so far so good. Wow, that's a really long decimal. We should probably figure out how to truncate that. We can round that to 2 decimal places. 3 decimal places is what we have in the example. There we are, 0.513.
Really, really fast, and
Oh.
we can type as fast as you can think. So
I'll pause here for a second.
we're kind of overwhelmed.
Okay. Let me pause here.
On the line that says like print and then gallons of gasoline, there's like a yellow parentheses and there's something green. What is the green thing?
On the line that says print gallons of gasoline. So we have print gallons of gasoline.
The green thing after the yellow half parentheses on the left, after print yellow thing and then green thing.
Print this yellow thing here.
Yeah, that yellow thing. What's the green thing?
The open parentheses is when our functions, they take arguments. We have an open parentheses, and here we have a closed parentheses. So print is in,
Green after the yellow parentheses.
there's an F here.
What is the F?
The F is our format print. So the format print converts anything inside of these curly braces into code. As opposed to a string.
Only one side? Is only one side of it?
Anywhere you have a open curly brace, closed curly brace, so we have it in 2 locations here. So that enables us to put our parameters into the string.
Oh, that F. Okay, so F.
Yep.
F.
If we didn't have the F, let's look at what would happen if we didn't have the F. If we didn't have the F, it would just print the words gallons of gasoline, but we don't want it to print the words gallons of gasoline. We want it to print the variable gallons of gasoline so that we can use this with 10, we can use it with 9, we can use it with 500. So we want it to be dynamic and use it with any number. So we want it to be able to use the variable.
It's a little hard to see.
Let me see if I can zoom in a little bit here. This is better. Oh, that was too far. There we are.
I mean, same mistakes here back here. It's a good thing too.
Yeah, and then so
I can try zooming in one time. I think it's going to start cutting off our code. We can try this. Okay. I did zoom it. Let me try shutting off these lights. You guys mind sitting in the dark?
Not at all. No, we can see. Oh, yeah.
Yeah.
So I'm talking.
I'll remember that next time. It is better when the lights are off.
I don't know if like the end of that same row print as down the gasoline and squiggle. Yeah.
And yeah.
And so I need a little bit of time here. Like an extra parentheses at
Yes, if we click on the parentheses here, it should highlight to you the closing parenthesis. So we may not want, if we put an extra parenthesis at the end, that's a common thing that happens. It will give us a unmatched. So it doesn't know where the match is, where the
as far as like indents go, like does it automatically indent or do you have to hit tab?
You can do either way. It will try to automatically indent for you. Like nothing here is indented on this. I don't have any indentation here. It will try to indent for you. So if you create a function, for example, def my function, it automatically indented for me. So it will try to help you, but you may have to indent it yourself as well.
Yeah, it's going so fast I can't keep up.
Okay. Let me know when you guys want me to resume.
Are spaces important and it requires the squiggly?
The spaces between requires and the squiggly. If we don't put a space, that's a good question. Let's try it out. My favorite question is whenever we're curious about something to just try it out. So if we put no space between requires and squiggly, let's see what happens. Oh, now it says requires 0.513. And that's a little unreadable. That's not super friendly to read. So let's come back in here and let's hit the space. And oh, now there's a space there. So this space here is actually printed out to the screen. So it's important if you want to make yours readable. It's not going to give you a syntax error, but it does make your output more readable. I think these are kind of like the basic foundations of programming. And I think it's something that as you guys just, maybe for next time, we'll continue, we'll do assignment 1. Maybe next time I'll just have you guys try to give a stab at assignment 2. And then we can come back together after you guys have attempted assignment 2
And perhaps then everybody's like, I've tried this, I've tried these different things. I've had a moment to sit down and look at it and sit with it, and I understand it. I do want you guys to just try to even, you may not know everything, may not know exactly how to do it, but there's this joke in programming. Sometimes you'll see these people have these shirts and it just says they're better than average Googler. So I want you guys to stretch that skill set of just looking on Google, finding your resources for how to do it. I do want you to understand it. The questions that you're asking about whether or not there's a space or should have a space here, very, very good questions. I also want us to try to just get our feet wet, try to get some errors to produce, feel a little frustrated with the code, and then eventually have that aha moment. Nothing better than that aha moment when you get a piece of code working that you've been hammering away at for some time. Okay, the last line here that we want to print is the price in US dollars. And we know based on our requirements up here that this is basically what we want to print. So we can copy that down. So we know this is what we want to print, but we want to replace that $43.10 with our variable of price in US. And we have to put an F here in order for it to recognize that. And we don't have a price in US because we haven't created that yet. So we need to create a variable called price in US and define our calculation for that. Let's scroll up and see what our direction said for that. The price in US is formatted to 2 decimal points. The average price of gas is approximately $4.31 per gallon. So it's going to be 4.31 times gallons of gasoline. 4.31 per gallon should give us the price in US. So if we say 10, now we have our, doesn't look very pretty. We probably need to round that to 2 decimal places. In Python, there's a function called round, and we can tell it how many decimal places. So the first parameter is what we want to round. In this case, we're passing our price in US dollars, and we're rounding to 2 decimal places. So 43.1. We cut off our 0. There's a format print that we can apply to that, but this is good for now. I think this is a good starting spot. I'll pause here for just a second. All right, I think we have 2 more after this, number averager and palindrome, 2 more. So I do want to get through assignment 1 because I think it will be helpful to you guys, and this is recorded so you can come back to it. Okay, number averager. We want to write a script that prompts the user for 2 numbers. We want to prompt the user for A, and we want to prompt the user for B. And then we want to prompt the number to enter a type of average based on these 3 averages below. There's an arithmetic mean, there's a geometric mean, and there's a root mean squared. So there's A plus B divided by 2. There's the square root of A times B. There's the square root of A squared plus B squared divided by 2. So based on how their selection, we want to give them a simple response and return to them the output of the correct average based on what they asked for. Okay, so this is what the program should look like. We're really creating full programs now. Please provide the first number to average. We'll give it a number, and that will get stored into A. Please provide the second number to average. They'll provide a number. We'll store that into B. And then please select the type of average, either the arithmetic mean, the geometric mean, or the root mean square. And then we're going to ask them to enter a number, 1, 2, or 3 from the list above. And then we're going to return the results of the calculation. We're going to run the calculation and return the results. So first into A, we're going to store the input. And should we always expect ints or floats? I think we'll do a float of input. Please provide the first number to average. We're going to store that into A. Then we're going to prompt the user, please provide the second number to average, and we're going to store that into B. And we're just going to test to make sure that works. Let's provide 1 and let's provide 2. Great, we didn't get any errors. So we're testing our program as we go and as we build it. The second piece is that we need to display these options for them. And maybe first, let's just start with one option, test the code, and then we can start with the other 3 options. Like I said, build in pieces. So we know we need to get them to enter a number from 1 to 3. Selection equals input. Bad. Okay. We know that we eventually need to, so first part here is enter the first number to store into A. The second part here is enter the second number to store into B. Commenting your code can be very helpful, by the way. These green hashtags are comments, and they're not actually executed by the program, but they're things that tell other programmers what your program is doing. And it can tell you what your program is doing. So when you step away from this and you come back after a while, it can be a helpful reminder. And I like to use them as to-dos, reminding myself what I have left to do in the program. So we're going to ask the user to enter a selection. And we know based on that, we're going to have to do something. Follow, calculate the mean based on the selection. And we had a to-do up here, which we have to print the instructions for the program to the screen. Okay, so I'm going to pause here for just a second. So we're collecting A, the first number to average. We're collecting B, the second number to average. The next thing in this program we're going to have to do is print these instructions. Please select the type to average and the arithmetic mean. We're going to have to tell them the directions. And then we're going to have to ask them to enter a number, 1, 2, or 3 from the list above. And after, based on that mean selection, we're going to have to calculate the mean. For now, let's just do the first one. So let's print these instructions to the screen. If you want to do a multi-line print, you can use 3 quotation marks, and it'll allow your print statement to go across 3 lines. So let's just do one mean calculation. Let's just do the first one. Mean is equal to, so let's call it arithmetic. Mean is equal to A, we're just going to copy what we had up here. A plus B divided by 2. And then we have our final statement here. The arithmetic mean is, and it looks like there's a line in between here. So we may want a print statement. That's just going to be an empty line. And then the arithmetic mean is, our format print. Let's just test this out first, and then we're going to have to probably rewrite this. Okay, so let's say 10, 1. Great. Select option 1. Okay, so here's our kind of first pass working code. We printed to the screen first, provide a number. We provided 10. 10 got stored into A. Then it asked to provide a second number. We provided 1. 1 got stored into B. And then we printed some instructions and asked the user to enter a number from the list above. We entered 1. And then nothing happened based off of that yet because we're just testing our code. Then we calculated our arithmetic mean and we printed the arithmetic mean. Okay. So here's our code so far. I can only show part of this at a time because I'm really zoomed in here. But we know we have to calculate, if they give us a 2, we have to do the geometric mean. And if they give us a 3, we have to do the root mean squared. You guys learned about control flow, which is controlling where your program goes and how it works. That's what we're going to use here. We're going to say if mean selection is 1, we're going to calculate the mean as A plus B. Elif mean selection is 2. We're going to get rid of this. Elif mean selection is, why am I have an error here? Oh, sorry. All right. If mean selection is 1, we're going to calculate the arithmetic mean. So if mean selection is 1, calculate the arithmetic mean. Else, if mean selection is 2, calculate the geometric mean. Else, if the mean selection is 3, calculate the root mean square. Okay, so what's happening here is we're asking the user to input a number, and they're returning a number. That number is getting stored in mean selection, and we're comparing that. If it's 1, we're calculating mean one particular way. If it's 2, we're calculating it a different way. And if it's 3, we're calculating it a different way. When we print to the screen, we're printing the arithmetic mean is mean. So based on which of these trees we followed, if we followed mean is equal to this one, then that's what gets printed. If we followed mean is equal to A times B, if it's a geometric mean, then we're going to print the geometric mean. So we're controlling the flow of our program.
Do you ever have to like save, or does it automatically save everything?
Oh, it'll automatically save. That's a great question. It's like Google Docs where it saves automatically. It's equivalent to that. So here we said 10.1 and the output was 7.1. Let's run this again. Let's run 10.1, but let's choose a different option. Let's choose 2. Oh, look, we get a different mean now.
Now we got this arithmetic mean. Oh, I should say the mean is. And 10, 1. And if we choose 1, oops, where'd that go? Now we get a different mean, 5.5. So we're calculating the mean in different ways based on what we're telling. We're collecting input from the user, and the user is directing how the program behaves, which is pretty cool. We're kind of like designing a whole program now. So like the foundations of video games. Okay. We're gonna do one more.
And then like this was something that I opened up and then I put it in Colabs now.
Yeah.
Will it stay like under my log? Will it stay like modified
Yes, it will stay modified.
and will automatically like stay in Colabs in my Colabs?
Yep.
Modified?
It will. Yeah, good question. Just like your Google Doc doesn't change or your Google Excel sheet, Google Sheets won't change. It behaves a lot like that. So it'll stay modified. That's why when I gave you guys Google Drive access, I gave you all view access, because if one person modified, that's why I'm having you download those and move them to your own instead of editing them on there. So you guys all have view access to the student drive as opposed to edit access. We're going to do one last one, and then I'll make the final question a bonus question. So we'll only grade through the income tax 20 points. Palindrome will be worth 20 points of extra credit. If you guys want to give a...
When is this due?
This will be due, I think we're going to go through how to submit on Monday. So if you want to submit it Monday, but I'll also record it so you guys can submit anytime. I would set the final due date at the Saturday after class ends.
Okay, and then so the next Wednesday is the last class?
Yeah.
And what's gonna happen there? We're gonna teach more and then take a test?
Yeah, so next Monday we're going to do object-oriented programming. Wednesday we'll cover so we'll do classes. Wednesday we'll cover any content we didn't touch on in object-oriented programming. I'll drop the last assignment because that is object-oriented programming. I think we've been a little more in the details in this class, which is good. I want you guys to be grounded in the material. And then we'll take the exam, the last part of the class.
What's the exam gonna be like?
I can share that. I can share after this. I have to open it up and look. I can tell you how many questions there are, what types of questions, if they're open-ended. So I'll give you guys a count of, hey, these are the multiple choice questions. The exam won't cover any object-oriented stuff. So it's only functional scripting. So everything up to the last piece of content was actually just our packages stuff. So today's all hands-on. So I try not to put new exam content the week of the exam because that's just way too much. So no object-oriented in the exam. Yep. So that's why I put object-oriented in the last week. It is the most advanced concept. It is the hardest thing to grasp. And really, people spend an entire college semester on object-oriented programming. But I do think it's helpful for you guys to know because it gives context to like how programming actually works in complex, like sophisticated software systems. So I think it's helpful. Okay, so it'll be like operators, it'll be variables, objects, data types, including basic data types, int strings, lists, collections, including Python dictionaries, tuples, and then functions and packages. Okay, I think I might have missed something in there. I think I almost got them all.
Tonight when you did this on the board, is there like, were you recording it? Is there a way to record it or?
I recorded my voice. We can take a picture. You guys are welcome to take a picture for sure. I was not recording the board, and this is.
How would you do that?
How would I record the board? Oh, last time they had moved the table up there, but I used to have the table down here, and I would stand over here and my camera would be pointing at the board, and then I could go upward. This room's just like a little weird from a setup perspective. Next time, I'm gonna redo this cart and make it a little easier to do. It's just funky room setup. When I do the machine learning course, though, we do whiteboard a lot, but I always have my camera at the whiteboard. That course is upstairs, and that room's a little, I don't know, there's just not the projector and everything in there. This is nice, but I don't know, it's not a great setup with the whiteboard. Sorry, I'm getting distracted. The tax income. So we're going to do this last thing, tax income, and then the last section here under palindrome, I'll make that one extra credit. So you don't have to do it. Let's do tax income. So mythical island nation, and it has a really simple tax code. The first $1,000 of income is taxed at 5%. The next $1,000 is taxed at 10%, and any income beyond the first $2,000 is taxed at 15%. So let's complete the following script that asks the user for his or her income and outputs the amount owed. We're not going to worry about finding. So let's enter the income first. Income equals, please enter your income. And we know at the end we have to print a print line and then print the tax owed is tax owed okay, and we're going to build to tax owed. So the first $1,000 of income is taxed at 5%. The next $1,000 is taxed at 10%. And any income beyond the first $2,000 is taxed at 15%. Any thoughts on how we might approach this? I'm going to try to put this in the code.
If income equals less than 1,000, then tax equals 1,000 times 0.05. The cumulative part, the cumulative thing, it would be plus.
You're right. So 1,000 or 5% tax owed. You can't start a variable with a number, percent 5 tax owed. Anything beyond 2,000 is 15%. Okay. All right, we have percent tax owed. So you're saying it has to be cumulative. So we're going to have tax owed is equal to this plus, okay.
Yeah, but if you just put the if you make one of that, it's already calculated with %5. So you won't go through the accumulation. If you put in the if loop, it will just skip it.
How should we handle that?
But you have to have it in every row. Well, not really. So
If income is
it's like you have to remove the 1,000.
more than 1,000, but less than 2,000.
If it's greater than 1,000, then we have to remove the 1,000, you said? So
Well, I was going to say, like, could you say it all in one line? Like, if
Uh-huh.
income is more than 1,000. Yeah.
No, the first 1,000 is still at 5%, right?
uh-huh.
So
Yeah,
that we
so
have
we-
to subtract.
Yeah, so so if income is more than 1,000,
Uh-huh.
then percent 10 tax owed equals, then for parentheses, percent 5 tax owed plus. Parentheses plus. Income minus
Yep, minus 1,000 times 0.1. I meant to make this 1,000. There we are. Okay, I think we're almost there. It's the percent tax owed. I think we want this to be 0.5 there. Does that make sense? So percent 10 tax owed is going to be 5% of 1,000 because we know it's 1,000 because income is greater than 1,000 plus income. And I'm going to double wrap these to make sure that's income minus 1,000 times 10%. That sounds right. All right. What if they make more than 2,000? Should we follow this same pattern? Should we say
percent tax owed plus? Oh, so okay, plus so you would do the same thing like 0.5 times 1,000 plus 1,000 times 0.1.
and then we'll have to take 2,000 off here, and this will be 15%. What's the problem we have here with our if statements? If greater than 1,000, if greater than 2,000.
Else thing?
It's just going to take the first one. So you were on the right track before when you said if greater than 1,000, but income is less than 2,000. Okay, I think that's right. We should change these since they're independent events. They can all be tax owed. And now we should be able to print this. Let's try it. 1,000. Tax owed is 50. That sounds right. Let's try 2,000. Tax owed is 600. Somebody sanity check me on that. That does sound like a lot. 10.
Because it's 1,000 times 50%. Yeah, they're 50%.
Oh, see, this is why we sanity check.
The other one, that last line is also 50%. That last one.
Oh, you're right.
That's
those-
tax.
Man, we're just taxing the rich people here, guys. We're taxing the rich people. All right. Tax owed is 50 on 1,000, and let's test it on 2,000. 150. Yep. Good job, guys. We did it. This is a real program. This is a true program. We're really writing stuff that actually functions and does stuff. This is awesome. This is good. Okay, that's it. That's assignment 1. And if you guys want to try palindromes, there's a palindromes piece here that says you can write a script that prompts the user to input a one-word string, and using a loop that counts downwards, print the letters of the name in reverse. And you can't reverse the function using the slice method. For this problem, you should use string.lower and upper. And to change, let me just scroll down. So for example, palindrome, if they enter the name Paul, make it go the other way, enter the name Anna, and detect if that is a palindrome or not. So if you guys would like to give a stab at that, feel free to. But this is enough for the assignment. This is complete. And I think we'll call it good for today because I don't want to get into assignment 2 because we only have like 15 minutes left. So this is good. I'm going to stop the recording, see if there's questions.